Hello everyone and welcome back to Education Foundation. In today's video, we'll be looking at the problem below. This problem states that a series RLC circuit has R equals to 15 ohms, L equal to 0.2 Henry, C equals to 20 microfarad, source voltage equals to 100 volts, frequency is equals to 60 Hz. Find the current I in the circuit. So the question is just simply trying to tell us that we should find the current in the circuit whereby the resistance is 15 ohms, the inductance, which is L, is 0.2 Henry, then the capacitance, which is C, is 20 microfarad, then the source voltage 100 volts, and then the frequency 60 Hz. So the first process or the first thing we are supposed to do or we are expected to do is to make a circuit diagram of the question below. So the circuit diagram will just be like this. So this is how the circuit diagram will be like. We are given the resistance as 15 ohms, then the inductance as 0.2 Henry, and then the capacitance as 20 microfarad. It is important to take note that as we have an inductor or capacitor present in this circuit diagram, we are expected to first of all find the inductive reactance, which is the opposition that is caused by the inductor in an alternating current circuit. Then we are now expected to find the capacitive reactance, so which is the opposition that is caused by a capacitor in an alternating current circuit. So once we have done that, we are now expected to now find the impedance of the circuit. The impedance of a circuit is the comprehensive expression of any and all forms of opposition to electron flow in a circuit. So in other words, it can be the sum of the resistance and the reactance in a circuit. That's what simply the impedance of a circuit means. Take note of the important things, which is the current of the circuit, the inductance of the circuit, the capacitance of the circuit, the inductive reactance, the capacitance, reactance, and then the impedance of the circuit. That's just what we are expected to find before we now find the current of the circuit using Ohm's law. Let's take down those points now. So R will now be equal to 15 ohms. From the question, R is equal to 15 ohms. L is equals to 0.2 Henry. The capacitance is equals to 20 microfarad, which is then equals to 20 times 10 raised to the power of minus 6 farad. It is important and essential that you convert it from microfarad to farad before you start your calculation. Then the inductive reactance is not given, that's XL, or the inductive reactance is also not given. Then impedance is also not given. So these are the first three things we are supposed to solve before we now finally find the current, which is the last thing we are supposed to look for. So these are the important things we should take note of before engaging into the calculation aspect. So now, as I said earlier, the first thing we are expected to find is the inductive reactance, which is XL. So the inductive reactance, which is XL, is given by the formula 2 pi FL. So in this case, our pi is 3.4 and our frequency is 60 Hz, and then our inductance is 0.2 Henry. So let's impute those values into this formula we are given, which will now give us 2 times 3.4 times 60 times 0.2, which will now give us 75.36 ohms. So that's our value for the inductive reactance. So now let's look for the capacitive reactance, which is XC. The formula of the capacitive reactance of a circuit is given by SC equals to 1 all over 2 pi FC. So this is the formula of the capacitive reactance of a circuit. So in the question, we are given that F is equals to 60 Hz, and then the capacitance is equals to 20 microfarad, which is the same thing as 20 times 10 raised to the power of minus 6 farad. So we are now imputing those values into this equation, which will give us 1 all over 2 times 3.14, which is the value of pi, times 60 times 20 times 10 raised to the power of minus 6. So now this will now be equal to 1 all over 0.007536. So 1 divided by 0.007536 will now be equals to 132.69 ohms. So now that we have found the capacitive reactance, we are now expected to find the impedance of the circuit, which is given by the formula Z, that's the impedance of the circuit, is equals to the square root of the resistance, or the square of the resistance, plus the difference between the inductive reactance and then the capacitive reactance, all in square. So this is the formula for the impedance of a circuit. Our value of R we have from our question is 15 ohms.
Our inductive reactance, which is
75 ohms, which we have here. Then our capacitive reactance is
132.69 ohms.
0.69 ohms, which we have here. So we are now expected to substitute this value into the equation that we have here. Which will be equals to 15 square plus 75.36 minus 132.69 bracket close square. Remember, all of this is in square. So when we further evaluate, it will give us root 15 square plus bracket open negative 57.33 bracket close raised to the power of 2. When we further evaluate, it will be equals to root 225, which is 15 square, plus 3,286.728.9. So then this will now be equals to 225 plus 3,286.7289 will now give us now be equals to 59.26 ohms. So 59.26 ohms is our impedance of the circuit. So now that we have gotten our capacitive reactance, inductive reactance, and then finally our impedance of the circuit, we will now make use of this impedance of the circuit to find the current of the circuit. So we are going to now make use of Ohm's law. So using Ohm's law, which is V equals to IR, we are now going to substitute the value of R with the impedance of the circuit, which is Z. So V will now be equal to IZ. Now apply the change of surrogate formula. The current will now be equals to V all over Z. So from our question, the voltage of the circuit, which is V, will be equal to 100, which will now give us 100 all over the impedance of the circuit, which we have solved to be 59.25. So then when we now divide 100 by 59.25, it will now be equals to 1.6878, which is approximately 1.69 ampere. So that is the value of the current of the circuit that we have in the question. So hence, this is our answer for the current of the circuit. If you found this video helpful, don't forget to like, subscribe, and drop your questions in the comment section below. Thanks for watching, and see you in our next video.